Metallurgy, test number 5, review. The ability of a metal to resist changing its shape or size when external forces are applied is called what? Strain, stress, elasticity, or strength? The big D. Uh-oh. Strength, 69% of you were 100% correct. Stress that pulls something apart is called what? Oops. Tensile, compression, shear, or torsion. This should be automatic, right? 94% of you are absolutely correct. Tensile stress pulls it apart. Stress that twists a material is called what? Tensile, compression, shear, or torsion. %94 of you are correct. Torsion stress. Stress that pushes something together is called what? Tensile, compression, shear, or torsion. Compression, 86% of you are correct. Stress that is measured by an opposing load perpendicular to the axis of grain flow is called what? Tensile, compression, shear, or torsion. %93 of you are correct. It is shear stress. When the elastic limit is exceeded, it is called what? Stress, strain, elasticity, elastic limit, viscoelastic lag, or the yield point. %62 of you are correct in the yield point. That graph where it goes up, kind of goes down a little bit, it's a yield point. That is a flashing rectangle answer indicator. Change that is expressed in inches of deformation per inch of material length is called what? Stress, strain, elasticity, elastic limit, viscoelastic lag, or the yield point. Uh-oh. Strain, only 42% of you got that. So the other 58% should be looking at that in their notes and circling it right now and going, uh-oh, I have a test on this. When blank is applied to the metal, it changes shape. Fill in the blank with either stress, strain, elasticity, elastic limit, viscoelastic lag, or the yield point. I believe I know the answer. 79% of you are correct. Stress. The ability of a material to strain under load and then return to its original shape is called what? Stress, strain, elasticity, elastic limit, viscoelastic lag, or the yield point. %87 of you with a smiley answer indicator are correct with elasticity. Bounces back, right? What is it called when the closer a material comes to its elastic limit, the longer it will take to go back to its original shape? Stress, strain, elasticity, elastic limit, viscoelastic lag, or the yield point? I believe I know the answer. I definitely know the answer. 93% of you are correct. Viscoelastic lag. What is the greatest load a material can withstand and spring back to its original shape called? Stress, strain, elasticity, elastic limit, viscoelastic lag, or yield point? 80% are correct. Elastic limit. What is the ability to deform under compressive loads called? Also known as the ability to be pounded into a shape. 70%. Malleability. Ductility is kind of correct, it's close, but malleability is the best answer here. Stresses beyond the elastic limit that are still useful. Plastic range, brittleness, stiffness, ductility, malleability. That same graph, it goes up, goes down, and then kind of arches like this. That is the plastic range, right? It didn't tell you anything. That is weird. Plastic range, we don't care. We know better. What allows a metal to deform permanently? Plastic range, brittleness, stiffness, ductility, malleability. 77% of you are correct with ductility, right? Technically, malleability deforms permanently as well. But the definition that is better fit is ductility. Materials that do not form plastically, right? Plastic range, brittle, soft, ductile, malleable. Brittle, right? Hard, brittle, doesn't bend, can't take an impact. What is expressed through the modulus of elasticity? Plastic range, brittleness, stiffness, ductility, or malleability. Modulus of elasticity measures the stiffness of a material. 92% of you are correct. What is it called when parts fail well below their yield strength with no sign of plastic deformation? Impact strength, fracture toughness, fatigue, fatigue failure, fatigue limit, stress critical. Well, okay, got in. Oh well. 91% of you are correct. Fatigue failure. What is it called for measures of a resistance to extension of a crack? Impact strength, fracture toughness, fatigue, fatigue failure, fatigue limit, or stress critical. %of you are correct. Fracture toughness. Subjected to repeated loading. What parts? When parts are subjected to repeated loading? Impact strength, fracture toughness, fatigue, fatigue failure, fatigue limit, or stress critical. 86% of you are correct. Fatigue. Hitting it over and over and over, or putting some kind of a load on it. Areas in a test specimen that are integral in the testing. Impact strength, fracture toughness, fatigue, fatigue failure, fatigue limit, or stress critical. %83 of you are correct. Stress critical. What is the ability to resist fracturing upon an impact load? Impact strength, fracture toughness, fatigue, fatigue failure, fatigue limit, stress critical. 2, 1, and 73% of you are 100% correct. Impact strength, right? It's in the answer. What is the maximum load in PSI that can be applied an infinite number of times without failure called? I don't feel like reading them again. So I'm not. That's just being lazy. 100%, wow. Fatigue limit. is a slow, continuing slow plastic flow at a stress below the elastic limit. Creep, thermal expansion, coefficient of thermal expansion, amorphous metals or superconducting metals. Creep. What metals are not perfect conductors, but what metals are not perfect conductors of electricity, but very good? I guess that did make sense. Creep, thermal expansion, coefficient of thermal expansion, amorphous metals or superconducting metals. %. That's surprising. Superconducting metals. What are the metals that were in the notes?
Silver, copper, aluminum.
Silver, copper, and aluminum. Metals that do not form crystals when they solidify. Oh, I thought it was. Creep, thermal expansion, coefficient of thermal expansion. Amorphous metals, superconducting metals. Amorphous metals. What is it called when solids become larger when heated? And they also become smaller when cooled, right? I bet the answer is, in fact, thermal expansion. Oh. Didn't tally it again. Thermal expansion. Heat it up, becomes larger, right? What is the rate at which thermal expansion occurs called? I bet you can't get this one through the process of elimination. Or did I put it on there twice? I've done that before and I got yelled at. You can't triple stamp a double stamp, turns out. Coefficient of thermal expansion, right? There's no wrong answer on this one. Are you going to blame the engineers for the Twin Towers collapsing? I was just curious to see this anonymously, right? Good responses. No, one person put them down. They're both the right answer. There's no wrong answer on that. Are you going to blame the engineers for the collapse of the Tacoma Narrows Bridge? %, say yes. 20% say no.
I feel like it was that drunk guy who left his dog in the car at fault.
Keep it together, man. We have one more slide. Are you going to blame the engineers for the Ohio State Fair ride disaster?
Are these on the test too?
No. These are just for FYI, for your information.
They should be.
Well, there's no wrong answer, so I mean, it wouldn't be a true judgment of your. Oh, you're not blaming the engineers for that one, huh?
I did.
All right, so if you had anything you were missing on there, you're going to want to review it. I'm going to go make copies, and then we will have the test.